All right, on this first one, what you need to do every time you're doing one of these two-column proofs, and I know some of them said paragraph proofs and flow proofs or flow charts. What did I tell you about flow charts? Do a two-column proof. Don't do a flow chart. All right. We didn't even go over how to do those. You probably know how to do them from English class and stuff like that because you make flow charts and all that. Maybe they call them something different. Who knows? But we're going to do all two-column proofs here. You write down the given, write down the prove. You have the diagram. The first thing you need to do, draw the diagram and come over to the diagram and start to label everything. Don't just try to start your two-column proof. You won't be able to do it. All right? It makes it too difficult. You got to think it through first. Notice when I do this, I'll make some notes over here. When you write an English paper, do you start off just writing the English paper? You write an outline, you write some notes, jot down some things, what you're going to write about. All right? Lay it on with this. We're putting this in our notes, so try to hurry and get caught up a little bit. So that's what I'm going to do. I'm going to have some notes over here. First thing they tell us, RQ is congruent to TQ, which is congruent to YQ, which is congruent to WQ. Later on in the year, we're going to get to circles. QT there. In relationship to this circle, QT is what? It's a segment, that's true. What special segment? It's a radius. All right? We're going to have a theorem later on in the year that says, in a circle, QT has to be congruent to QR because all radii are congruent. That makes sense, right? Distance from the center of the circle to the edge of the circle has to be the same no matter where you draw. That's why it's a circle. So not only are these two congruent, but what do you know about QY and QW? They're all congruent, right? So we can mark those. And that's what the first thing I want you to do on your paper there. Mark all four of those congruent.
About why, like, cause it gives you all the stuff that you already,
that you need
to know. It's like,
yeah, some of them are that way. Well, then that's all you write. If that's all you need to know, then that's all you write. So we know that. In this, we have our two triangles here. That's a pair of sides. That's a pair of sides. Let's draw some arrows here instead. So we got a pair of sides, a pair of sides. Last time we talked about ways to prove two triangles are congruent. What were those four ways? Four ways to prove two triangles are congruent. Well, right now, what parts do we have? A pair of sides and a pair of sides. Is that enough to say the two triangles are congruent? No. How many parts do we need? 3 parts. We have 2. So we're missing a part. Which ones of these 4 could we be using? We got a pair of sides and another pair of sides. We could be using side, 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 right? So we need another side in there. Or we could be using what? Side, angle side. So we need the pair of angles. Which pair of angles would it have to be? The included, right? It's the ones between the two sides. Go ahead, tell me. No, go ahead, say it. RQY. Those are the two we'd have to know. Well, do we know those two? Yeah, that was part of the given information. So we know those two angles are congruent. Do we now have enough to say these two triangles are congruent? Yeah, by what theorem? Or postulate, or whatever it is in this book?
Side angle.
Side angle side. Are we trying to prove the two triangles are congruent? Do we have enough to go all the way through our two-column proof then? Yeah. So now we start, make our columns. What do you guys call it? A T-chart? Is that what you guys call it?
I call
You call it a what?
it proof.
A proof. The whole thing is a proof. The chart itself is a chart. Well, I'm recording, Jonathan. Don't make me say things that.
Oh yeah, you're recording.
Don't make me say things, you know, about your intelligence and stuff that I'm gonna regret having on there for posterity. What's our first statement gonna be? What? What'd we say about the given? What'd I tell you earlier this year? Split it all up, all right? So what's the first thing we need to know? Very good. RQ is congruent to TQ. How do we know that? It was given. Now, something else I'm going to do, some books do it, some books don't. I don't remember if this book does, but it helps me out. Maybe it'll help you out. I know that I'm using this pattern right here, this blueprint, side, angle, side. So what I do is out here beside the 1, I know that that's a pair of sides in the two triangles that I'm trying to prove are congruent. So I put a little S. So I know right now I have one pair of sides. Is that enough to say the two triangles are congruent?
No.
So I know I need to go on a little farther. Now, let's try this. Let's confuse this a little bit. Normally, you would probably think to go where next? YQ is congruent to WQ. I don't want to do that. Why not? Do the angles. How come I might want to do the angles next? So it'll be in the correct order out here. Now, does it really matter if it's in the correct order out here? No, but it'll help not to confuse poor Kenneth here, because we know how easy he gets confused, right, Kenneth? So let's put the angles next. Angle RQY is congruent to, and if you put it the other way, if you put these two segments next, it's not going to hurt anything. It's not like it's wrong. How do we know that those two angles were congruent? Given. Guess what I write out here beside the 2? Little a. So right now we have a pair of sides, a pair of angles. Is that enough to say the two triangles are congruent? No, we got 2 parts. How many do we need? 3. Where do we get the other? The other pair of sides. What were they? How do we know that? Guess what I put out here beside the 3? Do I have enough now?
Yeah. That's all you gotta do.
Now, once you have enough to say the two triangles are congruent, guess what you say next? The two triangles are congruent. And that's, sometimes we'll have to match up the triangles. Here, they've already matched them up for us, so we don't have to worry about it. Remember I said you'd have to like flip them to get them to match up or rotate them or something? Well, here they've already matched them up for us, so we don't have to worry about that. Hopefully the book's smart enough that they matched them up correctly. Triangle QWT is congruent to triangle WQT. Don't know my alphabet. How did we know that those two triangles were congruent? Side, angle, side. Listen closely now. If your reason is like this one and it's two triangles, that has to be the, or I'm sorry, if your statement is the two triangles, your reason has to be one of those four things. It can't be anything else in the world, John, but one of those four. All right? Which question, Jalen?
Shouldn't that one triangle be R? Wait, never mind. I don't know. Why is it?
Yeah, it's hard.
Yeah,
I wrote it wrong. Triangle RQY. No.
wait, you said you don't have to switch it, right?
Triangle QWT is congruent to triangle QYR.
I still wrote it.
I looked up here instead of looking down when I wrote the stuff down. Yeah, it's a good thing you weren't that far yet. Hurry up though, because it's not going to be a good thing here in a minute, because
This
I'm
doesn't
going
make
to
sense. It's the same
Okay,
thing.
well then you're gonna, cause you've been blocking the board
I'm gonna
already.
go
Sorry.
first.
So again, if your statement is two triangles, your reason has to be one of those four things. So if I go through this, on a test, this would be worth 8 points. This question would be worth 8 points. Let's just tally up how many points you should be able to get on the test. Should anybody miss this one?
No.
That's 1 point. Should anybody miss the reason out here?
No.
That's 2. Anybody miss this one? How about this?
No.
So that's 4. This one? No. Should anybody miss that one? 6. Should you miss this one? No. Maybe. So let's mark that out. So you got what? 7 out of 8 points. No matter what, you got 7 out of 8 points. You can put side angle side there. You better know. You're gonna get confused. So you got 7 out of 8 points, plus, I just told you, and hopefully you can remember, hey, if I wrote two triangles over there, it's got to be one of those four things. So could you guess
Yes.
what kind of chance you got of getting it?
Well,
25% chance of getting it right, 1 out of 4 chance, right? It's like a multiple choice question. So you got 7 out of 8 for sure, plus, if you guess good, you got a 1/4 of a chance of getting the other part right too, and getting 100% on it. Okay, now are all of them going to be like that? No, some of them will be a little more difficult.
Wait, do we have a test on that?
Yep.
When?
Probably next week or something. So you should be able to do that every time. Now I'm going to erase this. Did you get it?
I got it.
Dustin, did you get it?
Yeah.
I'm just going to draw this real quick. Statements, reasons. Don't write any of this down. 1, 2, 3, 4, 5, 6. 1, 2. Please make sure you're numbering your statements and your reasons so you know that they match up. 4, 5, 6. We have not this problem, all right? It's not this problem anymore. It's just some new problem. And I'm telling you that it's got 6 statements and 6 reasons. What's going to be right here in number 1? Probably on most of these, what's going to be right here in number 2? Should you be able to get number 1 over here in the statement? Yeah, it's going to say it up here somewhere. How about number 2? We're proving these triangles are congruent. What's going to be right here in number 6? The proof. Triangle whatever congruent to triangle whatever. What's going to go over here in number 6? Side, side, side. Side, angle, side, angle, or angle, angle, side. How many points would this be worth? 12. Can't add 6 and 6 today. 12. How many points did we get for sure? Maybe not 6, at least 5 for sure. plus, if we guess good, maybe 6, right?
One.
So 50% if you guess and get it right. Is that bad? No. Because is that better than getting a 0 on it? Yeah. What percentage is 0 out of 12? 0. 5 out of 12 is like a 50-some%. That's a whole lot better than 0%. 50-some times better than 0, right? McKenna, you know that, right? 55 times 0 is 55 times better, right? Don't want that. All right, go ahead and copy this one down. Put it right there in your notes. I know when I look at Shane's, he's going to be able to read the next one
I sure will.
instead of writing it the way he wrote this last one. He was in a hurry then, right?
Fine.
Let's change that to get a handwriting.
Does this look like I do this right? I don't think I did.
Chances are I'm not.
Hey, you got real close. Transitive property should probably be substitution, not transitive. And number 4, yeah, I don't think you really needed number 4. But otherwise, yeah. So when we get to that one, you're gonna help me, right? I can read it so far.
Won't be a perfect picture.
All right, when you get a problem like this one, and the rest of them will be sort of this way. The last one wasn't too bad because the triangles, they came together something like this, right?
One.
So they weren't really overlapping each other or touching each other or anything else. So you knew exactly which 2 triangles it was. How many triangles are in this picture? 3. When you get something like this, it's got more than 2 triangles in the picture, then my first thing that I would do every single time, come up here and split off the 2 triangles that we're trying to prove are congruent. We're trying to prove triangle CDG, that's this triangle over here. My pen would quit messing up. Is congruent to this triangle on the right.
Where's the third one?
Third one's the big one. All right. So we're trying to prove those 2 triangles, and I'm going to split them off. Right. My letters with each one of them. D, C, G, D, G, E. So now I have 2 triangles that sort of look like this, right? I had them this way. I separate them. Okay? Let's go to the given. Given says triangle CDE is isosceles. What's that tell us? If a triangle is isosceles, what do we know about it? 2 sides are congruent, right? 2 sides are the same. In the book, they should have told you more information here because they should have told you which 2 sides were congruent. Because just because I say this triangle is isosceles, do you know which 2 sides for sure are the congruent sides? No. And they sort of marked it for you. They said these 2 are congruent. Are those 2 sides in our 2 triangles that we're trying to prove are congruent? Yeah, one of them's right here, one of them's right there. So that's a pair of sides. I'm going to write this in here. How'd I know that those 2 were congruent? Because they told us the triangle was isosceles. Just some notes so I know what to put in my 2-column proof. Somewhere I need to say, hey, I knew that these 2 segments were congruent because this was an isosceles triangle. Now, we're going to learn next week that if this is an isosceles triangle, Guess what's true about these two angles down here? They're also congruent. We don't know that yet, so we're not going to use that today, but next week we'll learn that. All right? So you could have used that also. So in other words, we have a lot of information here that we really don't need. Next, we go to the next given. They tell us G is a midpoint. If something's a midpoint, what's that tell you? Guaranteed, Grant probably wants to listen right now, instead of being off in his own little world there for a second. Another vocab test coming up here real soon. One of the words on there I almost guarantee is going to be midpoint. What's the definition of a midpoint? Point that splits a segment into two congruent segments. You guys want to come up with your own definitions all the time. I swear to goodness to you, every definition I give you is the shortest possible thing it could be. All right? I make sure that when I give you a definition, that's the very shortest it can be and be a good definition. So midpoint again, point that splits a segment into two congruent segments. All right? So what two segments do I know are congruent here? I heard like 75 different answers. CG and GE. All right? If that's the midpoint, then this has to be congruent to that. Are those two segments in our two triangles? Yeah, so let's come up here and mark them. That's another pair of sides. So I have a pair of sides, pair of sides. Is that enough to say the two triangles are congruent? No. Now, knowing these angles down here, if we know them, next week we will, then we could use side, angle, side. But as for right now, you don't know that rule, so we can't use those angles. So if we can't use side, angle, side, which one of the four things do you think we're probably going to use? You can read that, right? Which one do you think we're going to use? SSS probably. Well, that means we need the other pair of sides. What are the other pair of sides? What's the other side in this triangle? DG. What's the other side in this triangle? DG. You sure? DG and DG, does that make any sense? What do we know about that side? They share it, don't they? What property is that? Flip back in your notes one day from last time. It tells you in there. How do you know DG is the same as DG? Reflects with an X, not reflect. Reflexive property. Over here on the side, I'm going to start this. We're probably going to add to it a little bit every day. Things that got to come from right here. Casey's got to be able to pick them out from right here. You look at a picture, looks like this. First thing you should think of, reflexive property. They share a side. These are easy things that you should be able to come up with out of your head, that they won't give you in the given information, but you should be able to come up with it from right here. All right? And Dustin, we're talking about that, right, Dustin? What's the whole point of being here? To learn. What's another thing that you should be able to come up with? Some easy stuff that we've covered this year. I'll give you a hint. Vertical angles. Is that an easy one to come up with? If I draw a picture, it looks like this. What do you know about those two angles right there? They're vertical. They have to be congruent. Are they in the two separate triangles? Yeah. And we're going to add other things to this as we go. All right? So some things you should always look for as soon as you see a problem. Reflexive property, vertical angles. Look for those. Those are easy things to come up with. Easy things to get the extra points when we go down through and do this 2-column proof. So we now know that DG is congruent to DG, so we mark those because of the reflexive property. That's another pair of sides. Is that enough to say the two triangles are congruent? Yeah, I don't know. Oh, you drawing pictures. You better be paying attention.
Sure, Jesse might think so.
I'm gonna take it. Oh, yeah, I'm gonna take it and I'll
I worked so hard on that, don't take it.
I'm gonna take it and
Those are
when
my
I
notes.
email your mom, I'll attach this to it.
Those are my notes, you can't take my
And
notes.
say, this is what he does in class.
No, I didn't.
So we have enough to say the two triangles are congruent by side, side, side. So we should be able to go down through here and do it. Statements, reasons.
C, D, E, I saw triangle.
So triangle CDE is, and quit, isosceles.
Can you just put ISO now?
How do we know that?
Given.
Given. Now you can use abbreviations, but please make sure the abbreviation makes sense. All right? Because as soon as I let Jonathan do ISOS, the next time he's going to go, you know what? I'll just put IS. Then the time after that, you know, I'll just put I for isosceles.
And then I just won't put nothing.
And then the next time he just won't put anything. And
Just assume that you know.
is that a pair of sides in our two triangles? No. So we don't put anything out there beside it? Now, do we jump right to the next given?
No.
No, you use this. Knowing that that was an isosceles triangle told us what?
Two sides.
Which two sides?
D, E, and D, C.
All right, so DC and DE. And that's what we write next.
And it's given.
Now, was that given to us? No. How do we know that?
Reference.
Triangle was isosceles, and this is how you're going to write it. If triangle isosceles, you're going to write it like an if and then statement. If you have an isosceles triangle, then what did you know?
Two congruent sides.
Two sides congruent. Two congruent sides, however you want to say that. I'm always trying to find the shortest possible way because I hate writing. Now, the shortest possible way that still makes sense. All right? We're not going to pull the Jonathan trick and make it short and put like I, T, T, S, C.
Then I got another W. A random W.
Oh, a random W. Is that a pair of sides in our two triangles? So let's put a little S out here. Is that enough to say the two triangles are congruent? Where do we go to next?
G is
Right, if you run out of stuff to say about that, then go back to the given as long as you have given. G is midpoint of, excuse me, segment CE. I ran over a little bit there. How'd you know G was the midpoint?
See it.
Put a 2 right there. Put a 2 on the other side too.
Given.
It was given to us. What did that lead us to? CG is congruent to GE. That was a pair of sides, right? So we'll put a little S out there.
If you have a midpoint,
You have two congruent segments.
Just give me what I tell you the definition of a midpoint was.
a point that splits a segment into 2 points.
Into
Or
2.
congruent segments.
And that's what I'm gonna write over here.
Oh.
Midpoint, again, I'm trying to find the shortest possible way. Midpoint splits segment into 2 congruent segments. Now, it might not sound like the shortest way, But when you can use the symbols and stuff, it ends up being the shortest. Midpoint splits the segment into two congruent segments. Is that enough to say the two triangles are congruent? No, we got a pair of sides, another pair of sides. We're missing something. What are we missing?
Another side.
Another side. What pair of sides was it?
D and G.
Segment DG was congruent to what? Segment DG.
Hey, there's I told her
Segment DG is congruent to segment
there's
DG.
one where it's congruent to itself.
What's that? What is that? And
And
remember, we wrote the notes down over here
Someone smacked me.
so that we can refer back to it, right?
Oh.
And that's all you got to write over here is
Smacked me.
reflexive property. Anything equals itself. Hint, hint on the vocab test I was talking about a little while ago. Reflexive property. Anything equals itself.
then you just write the proof down.
That was another pair of sides, right?
Will you give us a list
Why
of
was
what we're
that
gonna have on
list?
there?
It was like,
I will
I've been giving you a list all year long. Yeah, every definition that we've had all year long.
No, not that.
Number 6, is that enough to say the two triangles are congruent? So where do we go to?
The proof.
Let's do this. Look. Does everybody see how they name the triangles? You're not allowed to name them that way. Somebody name this triangle, and you can't use CDG. Name this triangle on the left for me. DCG. So let's write that down. And that's going to be congruent to triangle. Now the reason I did that, because you got to match them up. What do you have to do to this triangle to get it to match up to this one? Flip it over. So D is going to match up to what over here? D. C is going to match up to what? E. And G is going to match up to what? What's our reason? That was given? I'm going to throw something at you. Do you ever write given in the last reason? Please don't do that. Don't ever write given down here. If you wrote that on that other test, I probably put on there never and put a bunch of quote or exclamation marks on it or something. If this was given to you, did we just waste our time doing all this?
Yeah.
Yeah. If I told you that the desk was brown and you take 6 hours to go through and prove it's brown, you're not very intelligent. All right? What's our reason? Side, side, side. So this would be worth 12 points. Let's see how many we should for sure get. Should anybody miss the first one?
No.
That's one. That one?
No.
Two.
No.
Maybe you missed that one. Maybe you don't have a clue what isosceles triangle is. I hope you do, but how about this one? How about this one? So that's 2 more points. How about this one?
No.
Yeah, maybe you don't know what a midpoint is. I hope you do, but maybe not. How about 5?
Yeah, we got that right.
You should, reflexive property, you gotta get reflexive property right. That's one of the easy ones. Vertical angles, reflexive property, stuff like that you have to be able to get right. Should you miss this?
No.
That's another point.
Maybe.
Maybe you missed that one. So how many points you got? 7 out of 12. It's over half, better than 50%.
Plus 140.
Plus a 4th chance of getting that last one right, because you know that this right here has to be one of those 4. So even by guessing, what kind of person is going to leave this one blank?
A lazy person.
I'll accept all those answers because they're all correct.
Dustin's like, he's like,
So what's that tell you about Dustin?
He's lazy.
He's okay.
He fits all those answers that you guys gave, I guess.
Just so hopefully.
All right, write this down real quick. I'm going to start this one, then I'm going to have you guys do it.
Oh.
Might be Shane since he's complaining the most.
I forgot to write.
He should have played
now.
So skip a little bit, then go back to what? Couldn't hear you. What? I won't yell at you.
No, you're gonna yell at me, can't yell at you.
Why would I yell at you?
Gotcha. Look at it, go yell at me.
Oh, because it's sloppy.
No,
Why would I yell at you?
there's no capitalizing.
Oh, you gotta capitalize it again. Don't forget your proof statement.
Oh, yeah.
Wait for real, we did.
The proof is underneath because I messed up and drew my picture too close to my word. So, fix it on your paper.
Super good. True. I'm going all these shapes. No, I'm not. Figure out the sheets that
That's everything.
there, true, bro. Learn the word thing.
As long as you understand it, that's all that matters. Yeah, problem. Which two triangles are we trying to prove are congruent here?
MRN and, or not MRN, but QN and M.
It's right here, right? So this triangle, everybody watching, and this triangle.
Yes. Your pen's not like you today.
Does everybody see those two separate triangles? So look at what's going on here. It's sort of like this. How many triangles are in this picture?
2, 3.
Keep going.
4, 5. 4. Oh, I see. 1, 2, 5. 5.
5?
4. 5.
Four?
It's 5. Yeah, 5.
You only see 3?
It's 4.
Oh, no, yeah, I see.
Got those 3, right?
Right.
I
did only do. No, there's 5.
What about those 2?
I didn't saw all of them, I just think.
So that's 5.
You saw all.
Is there any others? That's it, isn't it? 5 of them? We're trying to prove that these two triangles. Now you guys are having trouble seeing those. So again, what should you do? Come up here. Separate off the two triangles that you're trying to prove are congruent. Do they have to look exactly the same as the others? No. But when you label them with your letters M, N, P, N, P, Q, that way we know which two triangles.
What about that bottom?
Is R part of the two triangles that we're trying to prove are congruent? So right here we have vertical angles.
So wouldn't that be a nice one?
Are those vertical angles
Yeah.
going to be part of our triangles?
No.
No, they're not parts in those two triangles, are they?
Wait a
So even though we know that those two angles right there are congruent, is that going to help us with what we're trying to prove?
No.
No. All right, so sometimes you'll have extra stuff in there that won't help you. Now they tried to confuse you with this. Triangle MRN is congruent to triangle QRP. So which two triangles in this picture do you know are congruent? See, now this is what Grant's going to do. Grant's going to say, we already know the two triangles are congruent. Why are we proving anything? Is that what you're going to say?
Yeah.
Are these the same two triangles that we're trying to prove are congruent? No.
Next one down.
That's this one and this one. The one on the left and the one on the right, the smaller two. All right? Now, we're going to use this to help us prove that. If two triangles are congruent, if I know that these two triangles are congruent, then what do I know about all the parts that match up? They're congruent. So I can use some of the parts from these two smaller triangles to help us with this. Do we have any parts in the smaller triangles that are also in the two triangles we're trying to prove? Name me two parts in these two triangles that have to be congruent to each other.
No,
N,
in R,
N, P, and Q.
Say it again. I heard a bunch of different stuff.
N, C, and Q.
Is that in the smaller triangle?
in R, in
R,
R.
P, and R,
RP.
and R.
So that has to be congruent to that. The bad thing is RN in either one of these two triangles?
C, D, N, P, and Q.
Let's say what? I think you were sort of on the right track.
I was looking at those two, you got NP and NQ.
N, and Q. That's what I said. So
MN is right here, right?
Right.
What's it congruent to in the other one? Are those two in the two bigger triangles? They are, aren't they?
Yeah.
So what do we know about those two sides in the bigger triangles? They're congruent. They're congruent to each other, so is that a pair of sides?
Yeah.
Yeah. And we used the fact that they had to be congruent because of this, and we're going to put that in there somewhere, and when we get to that, I'm going to tell you what it is.
Can we,
Go ahead.
I just, never mind.
How about these angles? Angle M. Is angle M in one of those two triangles?
Yeah.
Yeah, it's right there. Is angle Q in this triangle? Yeah. Do we know that they're congruent? Are they going to match up from the two smaller triangles? Yeah, so we could use that also. I'm not going to, because we don't need it.
N, P, M, R, and Q are.
MR and QR. Now, is MR and QR in the two bigger triangles? No. All right. So let's do this. Let's go to the next given. Angle MNP. Is that in one of these two triangles up top here? It's right here, right? Let's put a mark on that so we don't confuse it with the others. And it's congruent to QPN. That's right here. So now we have a pair of sides. We have a pair of angles. Is that enough to say the two triangles are congruent? Not quite. We need something else.
Can we use
NP is congruent to what before Jalen burst her spleen over here? It's congruent to NP. How come? Reflexive property. Anything equals itself, right? Reflexive property. Is that enough to say the two triangles are congruent?
Yeah.
Yeah, by what?
Side angle side.
Side angle side. Shane, you didn't say it. You've been wanting to say side angle side all day long. You've said it about 1,000 times. You had a chance to say it this time, it was going to be correct, and you didn't even say it.
They got tired of it.
All right. So, can we go over here and prove that the two triangles are congruent? You knew it would come up sometime, huh?
Angle N.
Somebody go up there and write for me so I can sit down for a minute
We would use,
before I pass out. That's what happens, John, when we get to be this fat. Thank you, John. Tell my wife that.
Well, maybe says,
Number one, what are we going to write first? Which one?
Angle N.
Let's write the other one first. Put a 1 with it. Please make sure you number these. Triangle MRN is congruent to triangle QRP. Got your triangle symbol. Yeah. How do we know that? It's given. What did that lead us to? What did that tell us? Anybody remember back that far?
Nothing.
The congruent sides, which ones? MN and QP. So our next one's going to be segment MN,
N,
M, is congruent to segment QP. Now this one, you don't know the reason for yet. So Jesse's just gonna write this down. Make sure you spell it correctly when I tell you, all right? I'm just gonna tell you the letters, make sure you spell it correctly. C, E,
Did you say CE? What'd you say?
C, P,
P.
C, T, C.
Does that stand
All right,
for
say it
something?
for us, Jesse.
CP, CTC.
No, say it, say the word. All right, so it does stand for something. And that's what we're gonna learn here in a minute, and that's what your notes are gonna be for the day, is what that stands for. All right? Notice, what's the statement up in number 1? Two what? Two triangles, right? The only time you can use that CP-CTC that we have there is after you have proven that two triangles are congruent to each other. Well, we didn't really have to prove that those two were congruent to each other because they gave it to us, right? CP-CTC stands for this: corresponding parts of congruent, what do you think T stands for? Triangles must be congruent. So in other words, the two triangles, we take them, we match them up. What do we know about all the parts that match up? They have to be congruent. They have to be the same. Corresponding parts of congruent triangles are congruent. We're going to write that down here in a minute. Was that a pair of sides in our two triangles? So let's put a little S out there beside the two.
You can't see it.
Yeah, that's right. I can see it. Number 3. Where do we go to next? CP-CTC. Remember, every other letter is a what? C. Starts with a C, ends with a C, C in the middle. Then you have a P and a T. Where do we go to next after we said those two sides were congruent? Next given, so let's write it in there. Angle MNP is congruent to angle QPN. How do we know that? Given. Shane, come back to this world. Was that a pair of sides or a pair of angles in our two triangles? So let's put an A out there beside the 3. Is that enough to say the two triangles are congruent?
No.
No, we need something else, so let's do number 4. Where do we go to next? We're out of given information, so I guess we're done, right?
Yeah.
Because that means Tristan's got to come up with something out of that thing on his shoulders. Does anything ever come out of there, Tristan?
NP thing?
Nothing ever comes out of there? NP is congruent to NP. Stuff comes out of there. NP is congruent to NP. How do we know that? Reflexive property. Anything equals itself. Jesse can just write reflexive property, but you got to remember what it means. Anything equals itself. So Dustin equals what? Dustin, not me, Dustin. Equals itself. Nice spelling. Huh? Nice spelling. Was that a pair of sides in our two triangles? Yeah. So put an S out there. Is that enough to say the two triangles are congruent?
Yeah.
So number 5, what are we going to write? That. Right in there. You're right. The two triangles. They've already matched them up for us. I'm not going to make you match them up this time. Triangle MNP is congruent to triangle QPN. How do we know that those two triangles were congruent? Given. No.
That's it.
Not prove either.
That's it.
Side angle side.
I was just kidding.
come nobody on this side of the room believes that you were kidding?
I wasn't. Yeah, I was just related. See, you believe me.
No, I should have been right here down for you. You remember that? Hurry up, right?
Well, yeah.
You can do that. Or try to do it real quick. Get some of it down.
There is no math.
Should be.
Go ahead.
He would love to put a 0 on that test.
Marty and Jesse don't want you to go back there because in a couple of years, I know what they want you. Am I wrong?
If I draw you a picture, will you put on the
Oh,
board?
so you think they're just gonna let you hang around till you're like 35 or something? Your dad doesn't have a basement, so you can't live in your dad's basement. Huh? Yeah, that's true. But it's probably somebody else living there, isn't it?
For the moment, kick him out, my done son, and then
Do you think he's gonna kick them out? He does. Oh, does it?
why? Then why would he rent it to Sloth?
You don't know if they're Slav or not because they weren't Slav when they first moved in.
Over time, they're getting old.
Sort of got it?
Yeah.
Why, who's living there now?
Betty Crocker.
Actually, one of Hattie was cool.
So your aunt's not living there anymore?
No, she was that long.
Why? Really?
Yeah.
That's when you think all the kids are
I'll never swear.
All right, these are your notes for today. Write this down. We're going to go over this real quickly. We still got about 20 minutes. We're going to try to go back and do a couple other problems. Ah, shoot.
How many more minutes do we have?
I don't want to go back that far.
Okay. 30.
That's literally, I think 31.
Okay, 31. Big up there. I'm reading.
Title this. Title this.
CPC2T.
You can just add it right onto the bottom of the notes you've been writing, the examples that we've been doing, those problems.
Unless you're in the
Did you have actually
You'll be lucky if I remember your name after you're out of my class.
No, you don't remember me.
Will you remember me?
Why do you hate me?
You stop working on it, you're
I don't remember any students that I had in the past.
Oh, shit.
I gotta do something wrong here.
I'm just irresistible. That's how. Hey, you could be like, oh,
It's because he was my age.
But for the desk.
He thinks that, but
Hey.
Also, I was like, you ain't going
No.
because you sit down.
You go always
now.
Dude, Steven, he tells me everything that Preston does that is stupid that you just get aggravated. He doesn't.
I won't remember Preston. If I remember Preston, it won't be because of Preston. I'll remember him because of his mom, because I went to school with his mom. I won't remember his name. I won't remember, I'm sorry, but
You'll remember me.
God's honest truth, I won't remember any of you. A year from now,
Brain cancer.
John will be walking down the hallway and he'll say, "Hi, Mr. Eversole." And I'll say, "Hey, how you doing?" I won't have a clue who he is.
It's like at a family reunion, you're talking to cousin.
Dude, I'll bring it.
John.
Hey, how you doing?
All right, I want you to write down a couple of things with this. CPCTC stands for corresponding parts of congruent triangles must be congruent. Two things I want you to write down
Is
with
that a
it.
vocab?
Yeah, it could be.
Okay.
And I wouldn't want you to give a definition of it if I put CPCTC on a vocab test. That's what I'd want you to write out. Corresponding, tell me what it means. Corresponding parts, congruent triangles must be congruent. So if you know two triangles are congruent, the parts that match up have to be equal or congruent to each other. First thing, only use an emphasize only, after proven two triangles congruent. You can only use it after you've proven the two triangles congruent. So every proof that we've done up till now, we've stopped at the two triangles, right?
Yeah.
So that means this is going to add more steps on after the two triangles.
Thank you, Mr. Eversole.
So you can only use it after you've proven the two triangles congruent. I got to remember what the other thing was I wanted to say. After two triangles. See, it's horrible.
He's thinking.
We use after two, prove the two triangles. Must.
Mr. Eversole,
Yes.
I draw you a picture when you put on the board.
Probably not. If you do it, not during my class. If you do it not during my class,
All right. I got you. Let's see your eyes.
only use after, listen, just relax for a second. Gotta think. It's not like it's a big deal. Must. Oh, well.
He's thinking, you guys are just like,
If I remember it, I'll tell you guys. It's just something to help you.
So it's not too important.
It's not like it's something that you have to know. It's something to help you to make sure that you're using this correctly. Okay? So the main thing is you got to have, when you're doing a two-column proof, so if I'm doing a two-column proof now, this will actually make it easier on you. Oops, that should be a 1. Oh, I know what it was now. I will. So, if we're trying to prove something, and that's what this one says,
Mr. Eversole,
use when proving segments or angles. So if you're given a two-column proof, in your proof statement, what you're trying to prove says prove segment AB is congruent to segment QR, or something along those lines. All right? Instead of having the two triangles in the proof statement, it's got two segments or two angles. Then you know you're going to be using CP/CTC at the end. All right? So right away, if I'm doing this two-column proof, and this is my proof statement, guess what I could write in right here for the reason for number 6? CP/CTC. All right? Does that make sense to everybody? Michael, that make any sense? What's going to be right here? And the reason for number 5.
That's something.
Side, 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 angle, angle, or angle, angle, side. All right, don't do that. Stop, cancel. Oh no.
That was a real
Do that first. We have some two-column proof. I know you probably can't see that real well, but and it's saying the proof statement is prove angle A is congruent to angle Q. Change it a little bit. What's going to go right there is that statement. Angle A is congruent to angle Q. What's going to be the reason? CP/CTC. Number 5 right here is going to be the triangles are congruent, whatever the two triangles are, and you'll have to match them up. And then it's going to be one of those 4 things. What's number 1 up here going to be? Given. Probably number 2 is going to be what also? Given. So now there's 12 points. We don't even know what the problem says. We can for sure get 1, 2, hopefully you can match up the triangles. 3, maybe you missed that one because you guessed wrong. 4, 5, 6, 7. 7 out of 12. Not even knowing what the problem is. Just filling in stuff where it goes. Now, if you're still trying to prove triangles are congruent, are you going to use CPCTC? No. You're going to stop when you get to that one right there. All right? That makes sense.
Wait, so when do you go on to the
If your proof statement is like angles or segments. If your proof statement is 2 triangles, then you probably won't use CPCTC because you don't want to go farther. Problem number 3. Shh. Follow along because I'm going to hurry. I'm not going to write the given and everything because you have it there. I'm just going to draw the picture. Somewhat of the picture. Might not be exactly the same as it because doing it quickly.
It says X is the midpoint.
Number 3 on the paper, it says CPCTC. First thing, the given says X is the midpoint of segment AD. If X is the midpoint of segment AD, what's that tell us? AX is congruent to XD. Are those 2 sides in our 2 triangles? Yeah. Now look at this, because are we trying to prove the 2 triangles this time? No. So we know that we're going to prove the triangles, then use CPCTC in the last step or statement and reason. Okay? So that's a pair of sides.
Oh, those angles are the same.
It says A and B, C.
Says it's the midpoint of segment BC. So what's that tell us? What 2 are congruent? BX is congruent to XC. That's another pair of sides. Is that enough to say the 2 triangles are congruent? That's all the given. So what do we look for? We got vertical angles here, don't we? One of those things that you got to come up with off the top of your head. What do you know about these 2 angles right here? They got to be congruent because they're vertical angles. I'll jot that in there so we don't forget it. Do we have enough now to say the 2 triangles are congruent? Yeah, if these 2 triangles are congruent to each other, what can you tell me about those 2 segments right there? They're congruent by CP, CT, C. Corresponding parts of congruent triangles must be congruent. So we should be able to write this 2-column proof. Let's move quickly. What's our first statement going to be? X is midpoint of, what were the segments? How do we know that? It was given. What'd that tell us? If X was the midpoint of AD, that told us what? AX was congruent to XD. Segment AX was congruent to segment XD. Now, before we do the other one, I normally wouldn't want you to do this, but to make it shorter, what were the other 2 segments that be the midpoint told us? BX is congruent to XC. Now let's give our reason. What's a midpoint?
A point that splits this.
Segment into 2 congruent segments. All right, midpoint splits segment into two congruent segments. Was this a pair of sides in our two triangles? Yeah, was this a pair of sides? This is why I don't like doing that, because now we got two S's out there and that seems to confuse people sometimes. Is that enough to say the two triangles are congruent? What else did we need?
Another side of the vertical.
The vertical angles. What were the vertical angles? Name them for me.
D, S, or not D, A, but B,
Angle BXA has to be congruent to angle what? DXC. Vertical angles are congruent. Come on, Jalen, that's not very long.
I know, I just didn't know.
Vertical angles are congruent. What do I put out here beside the 3? Is that enough to say the two triangles are congruent?
A.
Yeah, now you gotta be careful. Somebody name the triangle on the left for me.
B, X, A.
BXA. Perfect. Here, I thought you'd miss that. Just kidding. Can you miss the first one? No, what you can miss is matching up the second triangle correctly. Triangle BXA, you gotta be careful. What do you have to do to this triangle to get it to match up?
Flip it.
Just flip it over?
We'll line it up with the other.
How do you line it up? You can't just flip it, you got to
Turn.
You gotta turn it. So the B is actually gonna lay over top of what over here? The C.
Why do you have to rotate?
Because this one that's got 2 marks on it, what do you want it to lay over top of?
Other.
The one that it's congruent to. So you gotta flip it around, huh? So now you know it, right? So you always gotta make sure you match them up correctly. So the B matches up to the C, X matches up to what? X, and the A matches up to the D. How do we know that those two triangles are congruent? What do we use?
S, S.
Remember, for the two triangles, it's always got to be one of those 4 things. What was it? SAS. They were all saying it wrong, weren't they? Jesse's over here trying to be funny saying SSA. Spill the bad word. Are we finished? We're trying to prove what it say on the paper.
Line AB is congruent to DC.
Line, or not line, segment AB is congruent to segment DC. How do we know that? CP, CTC. So looking down through this, should anybody be able to miss these first 2 points? So that's 2 points. Maybe you missed that one. You don't know what a midpoint is. Should you be able to miss vertical angles? So that's 2 more points. Should you be able to match up the triangles? Yeah. Got a 25% chance there. Let's say you miss it. Should you be able to miss this last one? 2 more points. So 7 out of 10, which is what? 70%.
Is that our homework?
All right? All right, your assignment's right here.